questions you might have. Fire away.
Well, you keep saying this is not a done deal. But as I think of it, you don't have a contingency plan. You don't have a plan B.
Yeah, so the only thing that, where the project is, or that the company is committed to is we have a, when you bid into the capacity auction, and the ISO selects you, you get a, what they call a capacity supply obligation. And in order to do that, in order to even participate in the auction, you have to post credit. So we've posted, several $1 million in credit to the ISO. And what they do is they hold that. If they give you the award, they hang on to that. And then if you don't get your permits, or something happens if the project doesn't get done, they keep that money. Yeah. So, the company pays, for all of the...
That's a great way to get money.
I'm telling you, it is a very, in our view, it's a risky venture. But that's the way the market has been structured for, probably about 15 years now. So it's, sort of, the way the ISO goes about it is, not anybody can just bid into the auction, right? You have to go through a series of steps. You have to file an interconnect request. They have to do a study, and then there's a division of the ISO. The ISO is independent, right? It's a not-for-profit, independent company that controls the grid. They dispatch the plants. They settle all of the whatever power agreements that are out there. They determine what the price for electricity that all consumers pay. And I can get into more detail if you want to know about that. So in order to be able to participate in the auction, you have to be qualified. So they have a division called the Independent Market Monitor. It's kind of like a legal technical team that they have. It's part of the ISO, but it's separate from the ISO. So what they do is they come in and they look at your project, your schedule, and all of these things, and they actually do another separate detailed electric transmission study, to see what's the impact of the project. Does it do what the ISO is looking for? So you have to pass all these metrics with them just to be qualified. So we went through that process. And just to give you an idea of how it works, last year's auction, they were looking for about 1,400 megawatts of new generation in New England, and there was 6,800 megawatts that had qualified and was competing for that. So that's a combination of not only projects like this, but also wind projects, solar projects, demand response. And demand response is like an industry pardon me, that, say it has a pretty high load, and, they agree, they sign a contract actually that, if the peak load gets to some point where the ISO needs to have people turn off the lights, the industry agrees to turn off their load, right? So demand response is about, it's about 2,400 megawatts, I think, in the total market. So they kind of look at all of those things, and they use the auction to to bring in new resources, and ultimately their goal is to try to make it as as cheap as possible for the ratepayers. And they're looking for the right mix, and so they kind of use this year over year auction process to call it transform the market, because as I think as you've seen in some of the literature that we put out there, that there's a lot of older generation that is still out there, still operating, that is in some cases 50, 60. There's couple of projects up in New Hampshire that are getting close to like 70 years old. That they're at the end of their life, and they have to replace them. So they're trying to, bring in the new resources and, keep the reliability there, try to help drive the costs down. So the past few years in New England, especially in this region, there was not a lot of new projects being proposed. So when they conduct the auction, they set a cap, a ceiling price, and then they have call it a floor price, right? So the auction goes through these like 5 stages where they start at the ceiling, people bid in, say, yep, I'm at this location, here's my price, here's my megawatts. And if there's still too much megawatts being proposed, they go to the next round. The price drops, the price drops, the price drops, till the point where people, the price drops to a point where, we would look at it and say, we can't, the price is too low, we would never be able to build the project, you wouldn't be able to get it financed, okay, we're out. So in this past auction, actually what happened was it got to the last round, and at that point, the project had the 2 machines, so we bid both, and then we just bid the one, because we didn't know, okay, the ISO, how many megawatts they want, because they don't tell you that. They want to keep the process highly competitive, so they try to keep all this information, very sensitive and secret. And we get to a point, it's kind of complicated, but what the market monitor does is when they qualify you, they also tell you this is the lowest price you can bid. So you get to a point where the price that we bid, that was our floor price. We were going to be out after that. So, and the reason they do that is that they're trying to have the competition drive the price down, and so that benefits the consumers. So it's I know it's kind of a long-winded explanation, but that's sort of the goal, the metric. What I see as a consumer, I think what we like to see is having the ability to improve the overall efficiency of the generation network, help bring in renewables, and and try to keep the reliability that you have for the electric generation system, where it needs to be, and you have to take a longer term view as to how do you get to where you ultimately want to go, right? And it takes years, because every year you go through this process. So you pick up a little here, you pick up a little there, and you go through these increments, but the whole goal, the way the thing is structured, is to try to get to that point. So I think when you look at New England, what's interesting about New England is the solar resource is kind of, it's okay, it's not great, it's not like Arizona, right? You're not going to get a lot of production out of solar panels. Just to give you an example, like if you were to put something in the desert, we actually have a 50 megawatt solar facility that we're putting in I think it's Nevada or Arizona, but that facility produces its peak power like 25% of the time, right? You can get quite a bit of power out of it. Here in New England, it's about 12 to 13% of the time, just because you have more cloud cover. You're up a little higher on the earth, so the angle of the sun is a little different. You kind of get into those things. So that's solar. On the wind side, I forget the name of the organization, but like an organization in the U.S. government, they've mapped out the wind resources throughout the U.S., okay? And when you look at New England, especially like Rhode Island and northern New England, where the wind is, what you need is actually, at the height of the impeller, the fan, it's about 80 meters up. they monitored the wind up at that elevation, and you need something that's on average about 6.8 meters per second. That means that's enough wind to push and, you know, produce power. And if you don't have that much wind, what happens is that in order, that machine has a fixed cost. If it's not producing as much power, then the cost it needs to get the power becomes a lot greater, right? So it's just not economic to build because, you know, no one wants to pay that much for power. So when they map out the wind resources, what you see is, like in Rhode Island, you have, you know, pretty good wind resources along the coast and offshore. That's why deep water wind is there. And then, you know, beyond that, it's kind of like offshore, you know, Cape Cod. Then you have to go up into Maine. And for some reason, up in Maine, up in like the, you know, the Great Woods and whatever, you know, it's pretty good wind up there. And then New Hampshire and Vermont, it's up in the mountains. But, you know, that's, you know, the White Mountains, the Green Mountains. You know, you're in a national forest, so it's kind of difficult to do there. So, you know, there's not a lot of places where you can really do wind. There are a lot of projects, though, being proposed up in Maine. And so as a result, what people are doing is they're trying to build electric transmission lines to get that power down from Maine. Some of them are even proposed, like going out through the Gulf of Maine and coming into like Boston, you know, an undersea cable, you know, to try to get that power in there. And you see other proposals, you probably read about them in the paper, where like they want to bring hydro down from Canada, right? So they're proposing a new transmission line, you know, highly controversial, unbelievably expensive. In fact, we have a project, it's in New York, upstate New York, and Massachusetts, Connecticut, and Rhode Island conducted a request for proposal. They were looking for power from just renewables. And so what we did is we teamed up with Canadian Hydro with a wind project. It's a 400 megawatt wind project, and with a transmission line company to get, you know, firm power supply from the New York project, backed up by Canadian Hydro to give 400 megawatts, you know, firm into this region. So, you know, those are kind of the complexities that you end up having to deal with when you try to, you know, to bring this in. So, you know, and I think I've said in the past that, you know, having a mix, you have to have a mix of you know, the renewables, you know, plus the gas-fired, and as you increase the amount of renewables, you know, in the region, you know, because you have this variability, you know, you have to have something that can sort of match that, you know, and the older resources that, you know, are currently out there. I mean, I could name a lot of them. You know, if I said the names of the plant, it may not mean anything to you, but, you know, these were plants that were built back in the 60s and maybe even early 70s. You know, but they have very long start times. They take like 12 hours to start. They're not very flexible because you can't change their load all that quick, just due to the nature of the technology. It's an old boiler where, you know, you have water wall and you're firing in, you know, gas or oil, and, you know, you're trying to control the steam to the steam turbine. It's like, it just doesn't like to move, you know. So you compare that to what we're talking about here, which is, you know, not only is it, you know, super efficient, but it's like, you know, you're almost like stepping on a gas pedal with your car. You can, you know, you can do whatever you want. You can control it. And the ISO likes it because it's got an advanced control system. You know, it's basically run the thing almost from a laptop. The ISO can send a signal in, and they take control of the unit, and they dispatch it as they see fit. So it makes for a much more you know, efficient system. That's the 101 of power generation. There'll be a test.
I hope we're listening. So if ISO controls what the cost for the consumers is. How can you say that the cost will go down for the people in this region?
Yeah, good question. So when you look at your electricity bill, you'll see there's an energy charge, there's a distribution charge, there may be a demand charge, right? The energy charge is really, like what it costs us to produce power, okay? So what they, the way they control or monitor, the energy charge is, it's going to get a little technical, okay? They came up with what is called a locational marginal price. They determine the actual price to produce power at every bus bar in New England. A bus bar is like right at our power plant or right at Ocean State Power. Any substation that you see, they calculate the price of what it is to produce power at that point based on the resources that are feeding power into that. They know all of those metrics. And so they calculate that locational marginal price on I think it's either a 5 or a 15-minute increment, 24/7. And they're constantly doing it. And so, that's the price. If we were to just, sell our power merchant, that's the price that we would get from the ISO. And so, so they control that price. They control is probably not a good word. It's probably, more like, they monitor and they in a sense set that price. Okay, I guess it's probably the better way to say it. And then the the demand charge that you see, that's sort of akin to the capacity payment that a project like ours gets. We get a capacity payment from the ISO, and what that payment really reflects is the fact that we're there, we're able to produce power, and what sets that payment is the auction, where they went through the auction, they tried to drive the price down and get it. So it's those two things that they use to control those prices.
You mentioned power plants in New Hampshire, Maine, whatever, that are 40, 50 years old.
Yeah.
If you compare emissions from this plant to that plant, I had made the assumption that the efficiency of this plant, the level of emissions would be far less.
Right.
Is that an accurate statement?
Oh, absolutely. In fact, I forget, there was a series of questions I think that we got from the town that we responded to late last week. They were asking for emissions comparison of our project to Ocean State Power. And, even though Ocean State Power is combined cycle, it was built 30 years ago. And, you look at, the emissions that they have reported. They have to report every year to the EPA. And, we look at how much you emit on a pound per megawatt hour basis. And so the emissions for some of the stuff that we have to report on are about either a half to an eighth of what they have. And that's due to two things. We're far more efficient, and we're putting in the latest technology for emissions controls. So yeah. So if you look at the plants in New Hampshire, those are the public service in New Hampshire facilities, Schiller, Merrimack. Those are old coal plants that were built in the 50s. And they haven't announced their retirement yet, but the Public Service Commission of New Hampshire, they're owned by National Grid. PSNH is a National Grid. National Grid was proposing to put in, some more pollution controls on that, right? And the Public Service of New Hampshire said, wait, these things are 50 years old. Why are you doing that? You guys, you know what, you should really, they said, you have to divest of those. So they actually have to sell those units by the end of this year. And, I don't know who's going to buy them. I mean, it's a tremendous liability.
So who would buy them?
Hmm?
So who would buy them?
I don't know. To me, it's kind of fascinating to watch because it's like, yeah, okay, who's going to buy it? What's going to happen to it? What are you going to do? I don't know. I mean, as a consumer, I look at it and say, yeah, you should shut them down. You know, but the ISO, I think, is looking at it like, well, you know, wait a minute, you know, we need the generation, so something has to replace it. You know, it's going to be interesting to watch, because I think it's going to be. I think they won't be able to sell it. This would be my guess, right? I don't think they'll be able to sell it, and they'll probably have to commit to the Public Service of New Hampshire Public Commission, you know, that they're going to shut them down by like 2020 or 2021 or something. Because you know what happens, you know, with these plants as they get older. I'm an engineer by training, and I used to design these things. And you know what happens is, you know, when you design a piping system like a steam or water, you put in a corrosion allowance. You know, the pipe is going to corrode so much per year, right? And typically, you kind of set it to say, I'll make the wall thickness enough so that, you know, it'll last for 40 years. And, you know, sometimes it does, sometimes it doesn't. There was a case, I don't know if you recall, but a few years ago, up in Salem, Mass, there was the plant up there. They had a steam explosion. I think it was 2 or 3 guys died. What happened there was they had a steam pipe had corroded, and it just let go, right? So as an operator, you know, as these plants get older, you know, you can't, you know, go out and inspect all the pipes. There's just too many of them, you know. So you try to monitor it, you try to, you know, see how it's going or whatever. But, you know, as the plant ages, your risk for something like that happening, you know, kind of goes up. So, you know, you just have to be, really, you know, careful on that. And, you know, that's I guess, a well-recognized risk in the industry. You know, when you have these old plants, it can really only run for so long. So. I guess, you know, kind of one of the ways I look at, you know, the industry as a whole, the things that, you know, what we should be doing, you know, I'm just using, you know, a metaphorical we, right? You know, we should be, you know, trying to improve the overall efficiency, reduce emissions, control the costs, and you know, make sure that you don't negatively impact the reliability. You know, the fact that the power is going to be there, because I think we can all agree, you know, energy is really, electricity is like the basis of, you know, the economy, right? We all see what happens, you know, when the power goes out, right? I have a generator at my house, and, you know, it's a pain in the neck. You have to turn that thing on, but, you know, we are so highly dependent upon electricity that, you know, we have to have it. You know, and so, you know, when I look at, you know, call it the landscape of the generation, you know, what I would ultimately like to see is for us to get to a point where, you know, we have a sustainable power generation network, right? I mean, we're not there yet. You know, how long it will take us to get there, I'm not sure. You know, we should take steps to get there. Given the current technology that we have, you know, with wind and solar and natural gas, that in of itself, I don't think will ever make you completely sustainable. Yeah, we have, you know, shale formations. There's a lot of natural gas there. You know, and some projections are it'll last a long time at our current consumption rate. We should be doing everything we can do not to have a plan that says we're going to use all that. We should try to get off that as fast as we can, and we do it by bringing in more renewables. And then ultimately, I think, you know, if we could have another technology, you know, kind of fill in that gap, you know, that would be great. I know early on in my career, I was designing nuclear plants. You know, at the time, this is, you know, back late 70s, early 80s, you know, it was, you know, they were thought that, you know, you wouldn't have to rely on foreign, you know, oil, or, you know, they don't have emissions. They do have other issues associated with them that, you know, I was quite frankly very happy to get out of nuclear just because I didn't really, you know, it was kind of tough. But that being said, one thing that the federal government has been doing now for 30 plus years is they're trying to develop a fusion technology, right? If you're familiar with the differences between the two, but if we could get fusion, that would be awesome, because then you have virtually unlimited supply of fuel. You don't have the radioactive contamination, the waste that you would have to contend with. There wouldn't be any, safety issue with regard to a failure or something like that. So it has, so many benefits. It's just incredibly complex. The Europeans are working on. They have a big fusion facility that they're currently constructing. It's going to be a test facility. It's kind of like full scale, using a magnetic confinement. And then in the U.S., we have one that's using what they call an inertial laser. I forget the term that they use it for, but it's kind of funky. But so these two competing technologies, if you will, they're trying to determine, hey, can we build it up at a scale and get it to that point where you could actually produce electricity. What I'd like to see actually is for the government to really put more emphasis on that, put more focus on that, because that would be, I think everybody would like to see that. So I know a lot of folks, have concerns about fracking. We don't frack, but we do burn natural gas, and I can tell you, the shale gas, our ability to access the gas in the shale formations really didn't come about until around 2007. And leading up to that point in time, I was still in the power industry, looking at trying to develop power plants. And prior to that, all of our gas that we used here, we either came from the Gulf Coast or from like northern Canada and Alberta. And those formations, they were running out of gas. There were projections back in 2005 I remember seeing that by 2015, 2020, when I hope to retire, the amount of gas that was available was going to be gone, and it was going to be very expensive. So I was working for a company, and they said, look, we can't develop gas. Well, we're going to have to develop some kind of coal, and they wanted to do what's called coal gasification, because you take coal, turn it into a gas, but you want to put it in a combined cycle plant, because that's the most efficient way to produce power. And there's actually one being built by a Southern company. It's called the Kemper coal gasification plant. And the issue with those is that it's like a coal plant. You still have all the emissions, right? And it's unbelievably expensive. I mean, it costs as much as a nuclear plant to build. And so it was like, I look at the ability for us to have, the access to the shale gas as being, kind of, thank God, because if we didn't have that, we'd be building this other thing just to try to meet, reliability needs. It's a story that people, you don't like to hear. I didn't like to hear it. I didn't like thinking about it, but that's the way it was. So, we talk about natural gas being a bridge fuel, and really what it is that it's those shale gas formations have given us the ability to number one, be energy independent. We don't have to rely on OPEC anymore and the Middle East. It really has transformed that energy component of our economy, and it's given us the ability that, okay, now let's make sure that we have public policy and government influence to bring in the more renewables and get the efficiency where we need to be and truly get to where we want to go.
There was a woman here for the last morning meeting that I came to, commented that European countries have really worked hard to develop renewables.
Yeah,
And I thought, and then she said, because they rely on Russian oil and they don't want to be connected to Russia in that
Exactly.
way. They don't want to be dependent
yeah,
on Putin
yeah,
to give them
right.
energy. But I thought if we were in that kind of crisis, if the United States had to develop renewables, we would.
Oh, we would. You know, no, it's an excellent point. If you look at, you know, in Europe, you know, the price that they were paying for that gas was
Phenomenal.
it was phenomenal, right? So there was, in of itself, that was tremendous motivation for them, you know, to get off that. Here, I mean, you know, I guess you could almost say that you know, the shale gas is kind of a double-edged sword, right? Because, yeah, it's plentiful. It's also cheap. I mean, the cheapest natural gas in the world is in Pennsylvania.
Where the economy is depressed and they'll do anything they can to get the money.
Yeah, in some parts of Pennsylvania, you know, the most expensive natural gas in the country is here in New England. But that's why I was saying, you know, what we need to do is really kind of, and we're doing it with, you know, dealing with legislators or whatever, have them institute policy to help, you know, bring on more renewables, you know.
Yeah, you're dealing with a very conservative, wealthy elite that doesn't care really.
Well, you know, you're dealing with, you know, either it's, you know, you have a change in administration, you know, Republican or Democrat, you know, whatever. You know, it becomes a political process, right? You know,
Absolutely a political process.
and it's not easy. You know, I think our view is that, you know, going the renewable route is the way to go. So, you know, we keep pushing on it, keep trying to make it happen. That's why, like, you know, the request for proposal I mentioned earlier, you know, when that came out, I mean, you know, we helped, you know, try to set the policies to create that RFP, and then when we submitted the bid, you know, we don't know, you know, who they're going to select or whatever, but, you know, we'll see. I mean, we'll continue to try to develop these projects.
Well, I'm still running hardcore. This land that you wanted to develop is probably the last pristine area in Rhode Island. You can go to South County and it's all very developed. It's not so pristine, and it doesn't have the amount of fresh, clear water that this area has. And I think about, now, these are my prejudices, I have to admit. I think about wind power off Martha's Vineyard,
Mm-hmm.
and the people who are rejecting it, they're the wealthy elite.
Yeah.
And here we are, you know, the rural bumpkins, as our governor would like to make us look. We don't have the clout to resist this kind of development of a very natural, pristine area. And it's disturbing. I mean, right now we can say, oh yeah, that's good. Just, you can't develop something like this assuming that there will never be any accidents. All that water around, all that oil going in there, it just, it really makes me nervous. Makes me want to move. I don't know where I would move. But I hate to, Rhode Island in the last, I've lived here 14 years. In the last 14 years has gone so gangbusters development oriented. The landscape has really changed everywhere, from the north part of Rhode Island to the southern part of Rhode Island. Take away this pristine area, makes my stomach sick.
Yeah. You know, unfortunately, when you look at trying to bring in, you know, new generation resources, where do you put them? Where do you kind of have to put them?
Yeah, I realize you need the water.
Well, you need, it's really like the gas pipeline and the electric transmission. That's what you need to be.
Yeah.
You know?
Now, I questioned last time why you didn't use this new technology in old plants. And you said, well, it would probably take about 5 years to redo these old plants. You know, take them down and rebuild them. It's gonna take at least 3 years to do this. So,
Yeah.
that's not that different. Take them down, put this in them.
Well, Ocean State Power is proposing, I think, to put up a peaker, an additional peaker at their site, so.
And that is one hell of an ugly area. When I drive to Uxbridge, I have to cover my face. I don't want to see what they've done to that area. You're talking about putting something in the middle of all this woods and marsh. I've seen Michigan do stuff like this, and it makes me sick. So, that's all I have to say. I'll try to keep my mouth shut.
That's fine, I mean, I'm here for the abuse, I guess. Not really, I'm really trying to, get a sense of concerns, and, I heard you express a
I'm just
concern about the
nervous
oil.
that the governor has made up her mind, and we have no.
I wouldn't say that that's true. I mean, the process is, there's a number of permits and, that have to happen. And, certainly the Energy Facility Siting Board is requesting an opinion from the town. The town, the town council, the planning board, they're going to have to vote on it. That's no certain, thing.
I'm so cynical about political processes, because I don't think the politicians give a shit about us. I don't. I think they've made up their mind. They will do what they want to do regardless of what their constituents think.
No, your local reps came out against the project.
Ooh, that's nice.
I have some questions.
Sure.
The application, although I understand it's a 36,000, foot view of this thing, there's not necessarily a whole lot of detail in here, but that's all we have to go by at this point. In the application, I read somewhere that it says that you could burn oil 60 days a year, but I've heard you say a couple times now that you can burn, you're applying to burn oil 30 days a year.
Yeah,
Can you clarify?
it's 30 per, there's 2 turbines,
Mhm.
it's 30 per turbine, so you could add them up to say 60 days, but it's really, one machine at a time for 30 days.
So would you burn both of them on oil at the same time for 30
Just
days?
one.
So,
Just one.
So it's 60 days then?
Yeah, it could be 60, but just one machine. So
Right.
that's the way we did the air permit application.
Okay.
Yeah.
So you could burn oil for up to 60 days total, 30 days per turbine.
Yeah, but the only time that we burn oil is when, because oil is, first of all, it's like 5 times the cost of gas.
Yep.
Okay.
Right now.
Yeah, right now.
Yeah.
And I don't think it's going to change because, the, natural gas, as I said earlier, it's, the cheapest cost in the world in Pennsylvania, and those projections are flat, going out 30 years.
So what if there was, a major disruption in the supply and you were forced to run on oil? Could you run both turbines on oil to meet the demand, or are you only allowed to run one?
Just
Or is it only capable of running one, this
just
particular plant?
one at a time.
Just one at a time?
Yeah.
Okay. So it's 60 days total that you can. Because, realistically, in the future there could be, another major, that pipeline's pretty old. I know they're trying to upgrade it in certain regards, but,
Yeah.
It's
Yeah,
very possible to have some.
Yeah, if there was a disruption, if they had some event that occurred, it caused the pipeline, there's 2 pipelines there, right?
Mhm.
A 24 and a 30-inch. Caused it, not to be available. I mean, that would be a huge problem for New England because, it's, that and the Tennessee pipeline is really the only way that, gas comes into the region.
Mhm.
So I would imagine that they would, be doing everything they could to fix it as fast as possible.
Yeah.
But that's why the ISO, they want us to have the oil. My personal preference would be, not to have it, but they have a reliability program, and they've set up the tariff,
Mhm.
which governs how the unit is configured and everything,
Mhm.
such that if an event were to happen and you didn't run,
Mhm.
you have to pay substantial penalties.
Mhm.
So it's kind of like an insurance policy.
Mhm.
That's the way we look at it. It's just,
Yeah, all right, so moving on, the visual aspects of this thing, there's going to be, stacks that are over 400 feet tall.
200.
No, 400. No, there's going to be 2 stacks, 200 feet apiece, based on your logic of 30 days, so there's going to be 400-foot
Well,
stacks.
they're 200 feet tall.
Well, 400 feet, you just said. Based on your logic, you're going to burn another 30 days a year per turbine. You add it up, that's 60 days. So let's add up the stacks, it's going to be 400-foot stacks. Those of us who live in houses that are worth between $500,000 and $1.2 million on the waterfront, that's 3/4 of a mile away, we're going to be looking at those 400-foot stacks. It's even in your application, you show. We're going to be looking at it. So not only are we going to be getting the pollution from it, we're also going to be getting the night light, on a pristine dock area. We're going to be getting these blinking lights, because I'm sure the FAA is going to require you to put blinking lights on it. I believe it's even mentioned in that. So, you're talking about compensating abutters, and I know you guys, you're business people, you're looking to basically look out for your own best interests, and if you could buy out 0 people, which, up to this date, I believe is the amount of people that you probably bought out. For those of us in high-end real estate, and I'm also a full-time realtor, we have and we are going to continue seeing a decline in real estate values in the town, even though you guys, your belief is that you don't. I like your beliefs, it's cute. But, we're working with the town right now, and, some of us, are going to be, seeking some injunctive release and stuff. You guys claim you want to be a good neighbor and you want to work with us. So for those of us that, are going to see a decrease in value and do want to move, are you guys willing to show a sign of good faith and just come out and forget the town, don't let our attorneys negotiate, but you guys step forward and say, listen, we get it. You guys that live in these pristine houses, high-end real estate always takes the hit first, and that's just how it happens because it's generally a more affluent client base. Are you guys willing to come out and help us with some property relief as we're looking to move away from this thing should it get permitted?
So the discussions that we've had with the town, the town has expressed those same concerns, right? And, they want to have, some type of, call it a property value guarantee agreement. So, we're looking at, how far do you extend that, right? How far do you go? If you were to say, well, you have to extend it, really far and wide, then, it's just, that's something that you can't do. You just couldn't.
But if you can see it, I would, if you can see the plant, you visually see the plant, and it affects, waterfront, we pay a premium for that. It's just anyone who understands and a little bit about real estate knows that you take a waterfront home, move it across the street, and you could lose anywhere from 20% to 50% of the value of that house because of the waterfront. People go to live on these waterfront areas for the pristineness, especially up in this area, is that we're not looking at, large structures like this, especially knowing there will be times a year where there will be evaporative emissions coming out of this thing, and that we'll see. So we want to know, are you guys willing to step forward and, help those of us who are, and I'm within a mile, and that may seem like a long distance away, but when you look, stand on my dock and you take a look left, all you're going to see is these 2 huge stacks. And the first person that comes to look at my house is going to say, well, what the heck is that? I'm like, well, it's, I'm not, what am I going to say? I'm not sure, and I'm not going to lie to them. I'm like, well, it's a power plant. It's a little guy, And it's going to affect our values, I guarantee it. And I had no choice but to move. We moved up to Barberville because I have a son that has some respiratory issues. So we moved up here, because the air was a bit cleaner than some of the more urban areas. I used to live on a lake in Smithfield. It's a little bit too close to some of the other Johnson landfill, things like that. So there are reasons that I have no choice but to move. I will have to move. And, we want to know, is Invenergy going to be that good of a neighbor to the town like you claim to be? Are you willing to step up and be like, yeah, you know what, there are people like you that are, that do need to leave, and, we're willing to protect your property values, and we'll help you out?
Yeah, I think that the best way I can answer that is, that we are talking with the town about trying to have a property value protection agreement. I can tell you, we've never done that before in any of our other, plants. And in the industry, I haven't seen it done really by anybody. So it's going to be, unprecedented from that perspective. We ultimately get to, some sort of an agreement, which will be unique. So I think, I don't know if it's going to be able to satisfy you,
So, in your talks with the town, are they doing something like with a zoning approval where it's a 200-foot to the boundary of the parcel, or are they talking a radius, like a half-mile radius, or what kind of talks are you guys coming up with for determining distance and abutters and however you want to define it?
Yeah, it's a radius, from the project. So we haven't, finalized that yet. The town's asking for certain things, and we're looking at it, trying to see, okay, what if we did that? Can we do that? That's kind of where we're at with it. It's still ongoing.
Okay, so someone that would say perhaps could be 0.8 miles away, I just happen to be roughly that, in your current talks, would I be outside of that zone?
I don't know, to be honest with you.
Okay.
The stack height, right now they are 200-foot stacks. You're giving me a thought. I mean, if we were to try to lower them so that you wouldn't see them, would that be better?
It could help. The only concern of that is that I've driven by zillions of power plants at night. You go around, you look at them, and there's a nighttime glow that comes from them. It just does. It's kind of.
Yeah, there'll be lights in the facility. We're trying to have them so they
Right.
broadcast down and not out the power.
So lowering the stacks could help some,
Yeah.
but there's still going to be a nighttime glow that's going to have a negative effect as well. And the power plant, itself, the physical location of the power plant in proximity to my house.
Yeah. I mean, you get a nighttime glow from the compressor station now, right? You see that?
Minimal.
Minimal. Yeah.
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 Yep. Is lowering the stack height a possibility?
It might be, yeah. I can ask our environmental folks to see, what could we do?
And what I would like to know is, have you guys done any, and I get this, unless I missed it in this application, have you done any studies on the actual change in air quality from the emissions?
Yeah.
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 Is it in the application?
That's all, it's in the air permit application. That was submitted to Ryder.
I saw some charts and things like that, things you're going to be putting into the air. I got that. Are you saying I need to go to DEM and this is going to be more detailed in here? Because here's my issue, those of us, and maybe a tall stack may actually help people that live closer, because it may send the pollution a little bit farther out. Shorter, it could make it, so it's kind of, you're cutting off your right arm to help your left arm a little bit, so, lowering the stack heights, would that help? Well, at the end of the day, and from my experience, every time I've dealt with a person who's going to spend $500,000 more on a house, man, these people are smart as a whip. They know what's around there within a couple of miles. They give me more detail than I could ever tell them about this stuff, and half the time I don't even realize what they're talking about. Hey, did you know there's a pig farm, 3/4 of a mile away? Nope, didn't realize it. I don't spend a lot of time over here. I couldn't see it from the road. And they're like, oh yeah, it's there. You should know. So these are the type of clients that we're going to be dealing with to buy these houses. So just the actual location of the plant, that's going to be a big problem for the majority of the real estate, but it's the high-end real estate that's going to take the real kick in the pants. They're going to get their jugulars cut, and their property value is just going to bleed out all over the place. So we're looking to see, if you guys are truly that good of a neighbor, are you going to reach out to those of us that are going to be hit, especially the hardest? I lose 10-20% of my property value. We're talking $100,000 or more. Someone with a $200,000 house, lose 20%. Be like, yeah, no big deal. It's 20 grand. I'm sorry, go away. Or 20 grand. It'll bounce back over time. And as the market settles out a little bit after this. But people like me, we're talking, in my opinion, significant amounts of money, and that's why we're concerned, because many of us in town we are going to leave. Even though we've been here, my family's been here for 150 years. So we're looking for Invenergy to, if you really want to be a part of our community, or well, I should say their community, it won't be my community anymore. But if you're going to be part of their community, we want you to show them, look, we are, and we're going to help out, those of you who are going to be affected financially from this. So I encourage you to, and I get it, you guys, you want the radius to be zero, and it makes sense from a business standpoint. I've been in business, my whole life, and, when I wasn't working as an engineer for 15 years. And I get it, I know these things work. You want to spend as little money as possible. And we, the people, want everything we possibly can out of you. We've got to come somewhere in the middle. And those of us, and I'm going to drive the point home. We have a couple of pristine lakes, right around there with some very high-end real estate. And, you know, those people, you know, as well as the people not in the lakes, they really do need to be protected. So, you know, I want to encourage you guys to not.
We're trying.
Yeah. I got a question on your water usage here. You know, it says in the summertime, you know, in the full summer conditions, you're going to use approximately 225,000 gallons per day. Assuming the evaporative cooler is running 24 hours a day, will that evaporative cooler always be running?
No,
It won't.
no.
So when that evaporative cooler is not running, what do you anticipate under the summer full load to be? It'll go from 225,000 gallons per day to
About 100 to 80 to 100,000 gallons a day.
it would increase.
No, decrease.
So when the evaporative cooler is not running, the
Yeah, so
water
what the
decreases.
evaporative cooler does,
Mhm.
you know, you have a combustion turbine,
Mhm.
the air comes in through a filter housing
Mhm.
to go into the gas turbine,
Mhm.
and what we do is we put like a water wall in front of that,
Mhm.
and that drops the air temperature to like the dew point temperature,
Mhm.
so the air becomes more dense,
Mhm.
and that increases the power output. So we can turn off the evap cooler, you know, anytime.
Mhm.
And the net effect of it is that you lose a little bit of efficiency and your output goes down.
Okay.
So, you know, really.
So in the full summer load, should you shut off the evaporative cooler?
You turn it off at night.
You turn it off, so you always turn it off at night?
Yeah, because what happens at night, right? You know, air temperature for the most part gets to the dew point, so the evaporative cooler doesn't do anything for you in that case.
Do you need to use the evaporative cooler in the wintertime or temperatures are generally, it's only for when temperatures are warm?
It's only when temperatures are above, like, call it 75 degrees.
Okay.
And then if the dew point is, you know, if it's a dry day, if it's, you know, dry 80, you know, something like that, you would turn it on then.
Mhm.
And you would turn it on, if, you know, as the peak load happens during the day,
Mhm.
you know, trying to produce more power, you know, meet the needs, you know, that's when you turn it on.
Mhm.
But it's either on or off.
So what, with the evaporative cooler shut off, you know, during the nighttime or when that's running or not, does that change the emissions that come out of the stacks?
It's only, it doesn't change the emissions, it's just water vapor.
Okay.
It goes through the turbine.
So water vapor that'll come out the stack. So there'll be a different amount of water vapor that comes out of the stack, whether or not you are or not using the evaporative cooler.
Yeah, so, yeah.
So does that mean, you know, in most, you know, power plants that I've seen, and I know this one's going to try to minimize that, you know, you have steam that, you know, emanates from
Yeah,
that.
so, you know, like compare it to Ocean State Power, right? So they have a cooling tower.
Yep, that one's a little bit.
Yeah, so they got a big plume of steam,
Right.
right? You won't see that here at all.
Mhm.
You might see a couple of pipes coming out of the roof or something, there'll be a little wisp of steam perhaps.
Out of the stacks.
No, you
Out of the
won't
building.
see anything coming out of the stack.
So it would come out lower, any evaporative
There'll
steam
be,
that comes out?
you know, just some small vents, I mean, it'll be like, you know, very, very small flow, if at all.
Will it appear to have more steam coming out of the stacks because of the temperature in the wintertime, given the cold air around? You know?
Yeah, if you have a pretty cold day and the plant is running, you would see, you know.
You'd see that
You'd see a
plume.
vapor plume, right, on a cold day. But for the most part, you wouldn't.
Do you have any questions? Thank you.
We're getting close to 11 o'clock, so if anybody has any more questions.
So we know that 40 parts per billion is the safe level for drinking
Right.
water contaminated with MTB. Do we know a safe level for breathing it? Because if you can't filter out 100% MTB, correct?
It's like 99.999. So what happens is the 40, I think as we explained, you know, we have the two vessels, right? We call this diagram. So you have the two vessels. We're gonna monitor for 40 here, but it goes through the second vessel. So what actually comes out of the second vessel, which is what goes to the plant, is you won't even be able to detect it. So we use the 40 at that location, you know, to size these vessels. And so ultimately what comes, it will be, drinking quality water, but the consent order that the Department of Health issued, prohibits the use of that water for drinking water at all. So, our plan is, to take the water and use it in the plant process, and in that process, clean up the aquifer. So we're not going to be, piping water at 40 ppb through the pipes. It'll be non-detect.
Okay.
But we use the 40 ppb, just as sort of like, that's the target. That'll be the design, but because of the design, that's not going to be the value that goes to the plant.
Okay.
Okay. I think, and the, RIDEM and the Department of Health will be looking at that and saying, yeah, okay. When I say okay, they're going to make sure that the design of the treatment facility is going to do just what I said. So that'll be the goal. And I'm sure Pasco Utility is going to want to do that too, because we'll pay for it. We'll help build it. They're going to really own and operate it. So, they have, I think, your interests in mind. They want to make sure that that's the way it's going to be. So I think, I know you guys have been struggling with the aquifer for I don't know how long, right? It's, it's contaminated, and, it'd be great to clean it up.
About 15 years it's been.
Yeah, because right now I think it's, the contamination, it's still there. It may have, abated a little bit, naturally, but it is, it's still there. It's still, I understand it's still leaching into, the Clear River. It's has the potential to migrate. So, wouldn't it be great to try to, it's not often that I think you have at least in my experience, have something like this where you can, provide that added benefit.
Who's responsible for maintaining all the filtration equipment and the pipelines up to the facility?
We're responsible for providing, Pasco is going to own and operate it, and the costs associated with that, we pay.
The installation or the maintenance?
Both.
Cool. So if there was, say, a water break, you guys pay for the repairs and maintenance?
Yep.
Yeah. How often are you guys going to test for contaminants like MTB and stuff coming out of after the filtration system?
It's continuous.
So there's a continuous MTB, like some sort of
It's
monitor on there?
You monitor it. It's like a grab sample, and you do it, but you do that, daily, a couple times a day perhaps. We're coming up with a design of that, but it has to be done in such a way that you can assure that it's not going to be, pumped down there.
Right.
But the two-vessel design, that gives you that other vessel gives you that sort of, backstop, if you will. Because the way the carbon works, right, is, it absorbs the contaminants until the point where it can't absorb anymore, right? And they call that breakthrough. So what you're really doing is you're kind of going in and you're taking your grab sample, and it's predictable, right? When you know there's the monitoring wells around the area that were installed after the contamination, you do samples from there, and you kind of look at, okay, how's the contamination doing, and you run it through your vessel, and so you can sort of predict when breakthrough is going to occur. And so, what you do is you schedule to have that vessel replaced prior to breakthrough. And it's actually pretty.
And there's a redundant vessel. There's a redundant vessel.
There's a redundant vessel there, yeah. So you take out this one, you got the other one, sitting there working, and during the course of that, we have tanks, on site, so that we could, shut the water down if need be, do the replacement, then turn it back on. So in that method, there are water supply treatment systems in the United States. There's one. I want to say it's a town in California. It's right on the tip of my tongue. But
San Jose?
they have.
Is it San Jose?
Not San Jose. It's. I'll think of it.
Yeah.
But they got like a 4 million gallon per day portable water supply system. For 60,000 people. The whole system goes through, this type of a treatment. And, there are other projects. I did a project with a former company down on Long Island where they had similar contamination, probably, nastier stuff that leached into the aquifer, and they have, this activated carbon filter treatment system to, produce drinking water. So it's not, it's pretty standard treatment, I guess is probably the best way to put it.
So I seem to recall from the case with the MTBE that, the higher flow rate they pulled out of this well, I think the levels of MTBE were actually increasing because they were pulling it at a faster rate. So with these carbon filters, if you're pulling, let's say the winter load where you get 1 million gallons a day flying out of there, what is that going to do to the effectiveness of the activated carbon filters, given that, let's assume that the MTBE goes up and the flow rate goes up? So
Yeah, good question. So, the way, when you look at, how do you treat a contaminated aquifer like that, you try to keep the flows, fairly constant, right?
Right.
And so one discussion that we've had with Rydam, they said, they asked that same question, and so the plan is to do it, slowly, right? Use tankage on site, do it slowly, so you're not like, shocking, the system. But that being said, what we would be doing is looking at it that, if you do cause that to happen, you just have to change out the vessel more frequently. So, we've included in our budget, what we think is, enough monies to have those change outs if you had to do that. So.
I know MTBE is a big concern for this town. As rightly so, there are a lot of people that were affected by it. Some even have passed away, believed to be caused by, cancer caused by it. I guess, you gave me some answers. It's still not 100% clear to me how often you're really going to be testing this. And also, from what I can tell, there could be pockets of, MTBE, because right now, I don't believe it's actually, down into the aquifer. It's down into the bedrock. We're pulling water up through the aquifer. It's grabbing this MTBE and coming out. We're going to filter it and try to clean it. So there could be other pockets, that may be sitting in between test wells, and as you draw it out, you could hit a larger pocket. Our concern is, and well, for those people that are staying, their concern is that you could pull this bigger pocket out, and now you guys, you're like, we only test it once a week, everything's been good, and you go to it once a month or once every couple of weeks. Now you grab this bigger pocket, and now, the filters aren't able to handle that, and now you have higher levels of MTBE shooting through the water lines because it just wasn't caught. We've gotten complacent, we figured everything was at a good spot, and, I think if you really want to, help us, and maybe you've already given the answers to Pasco Utility District, but there's a lot of unknowns there and a lot of detail that really needs to be figured out.
Yeah, I mean, that's something that we work out with Pasco, in concert with Pasco, right? Because, I think, they have to be satisfied that that scenario that you just described, doesn't happen.
I don't think we would ever be.
Yeah.
That would never happen. To be tested, say, okay, well, it's okay. We'll wait till next month and test it. That would
No, it's going to be a daily routine.
Yeah.
And ultimately, let's just say, we get to the end, right? And, somebody says, hey, I think this is now, drinking quality water. We've removed all the contaminants. Now the Board of Health will weigh in, and you would probably have to show, that there isn't anything coming out of that well with any sort of MTBE in it for an extended period of time, probably like years, before they would say, yeah, okay. So, I think.
All right, so the testing is going to be on
It's going to be us.
on Pasco Utility, okay. And that's all going to be paid for by Mind Energy.
Yep.
Okay. With all this additional testing stuff, and I'm going to divert the question now if I want for a second. Do you anticipate us having to hire any more employees at Pasco Utility District to keep up with, the increase of this new customer and the infrastructure?
I don't think so. I can't answer you 100%. I want to be honest with you.
Yes.
But no, I don't think so. There's also a fee. There's going to be a negotiated fee for operation.
Yeah, so we pay for the water, right? There'll be the fee that he mentioned. We pay for the maintenance, right? The replacement. It's really just, whatever it takes to operate that system, that's what we would pay.
How much water storage do you have on site?
There's a raw water tank, which is the water coming from the treatment system. That's about, I think it's like 800,000 gallons. And then we use that water, we demineralize it to use it in the steam cycle. And the demineralized storage tank is, I want to say it's a million gallons.
And that's the storage that will allow you to draw down on as you're ramping
Yep.
up on, especially in the wintertime when, you could be pulling
Right.
a million gallons a day.
Right. Yeah, I mean, the oil, how many times do we burn oil? The way we look at it, this past winter, we wouldn't have burned oil because it wasn't cold enough. The really cold winter last year, it was, 5 to 10 days. Previous 4 or 5 years, those winters were pretty warm. We wouldn't have burned oil at all. So the only time we would have burned oil is it's like once a quarter you have to run the machine on oil just to make sure everything is still working.
Right.
So you do that for 4 hours or something like that. So you would have that, but in general, you wouldn't do it.
In the wintertime, what's the case, under full load without oil, for water usage?
Oh, it's pretty low. I think it's around 100,000 gallons a day, 70 gallons a minute, something like that. It's not.
So it's lower than the summer full load because
Much
of
lower.
temperatures. And
You don't do the
much lower.
evaporative flow. Yeah, the only place we use water, it's really make up to the steam cycle.
Right.
So we have to produce the mineralized water. It goes into the steam cycle, and then in the boiler, you have what we call blowdown. It's kind of like how you have a boiler in your house and you have a little, drain. So you kind of let that little bit of water off so that you help control the chemistry because it has to be controlled so precisely. So, okay.
Anybody else?
All right. Thanks.
Thank you.